Okay, shall we start? Shall we proceed?
Yes, excuse
sir.
me, sir. Can we open yesterday's file again?
Yeah, I have. Yeah, please, sir. Open the yesterday file, sir. Hypercholesterol.
Okay, sir.
Please open.
2.5.1.
Yes. Let me check it out. One more minute. The file name is 2.5.1 hypercholesterol.
Yes.
So, good evening. Participant, yesterday's session we discussed about multiple regression and then binary logistic regression. Any questions for multiple regression? Do you have any questions to be clarified before we move on today's session? Is there any questions from the audience? If not, I will move on. I will start with the logistic.
Yes,
Yesterday
sir.
we discussed about the application of logistic
You can
regression.
start with logistics, sir.
So we have discussed about the application, when to use, how to use
Yes,
it.
sir.
What are the conditions? What are the assumptions conducting logistic regression? So logistic regression is meant for to predicting the outcome variable. The outcome variable consists of dichotomous. So based on some students' information, whether the students can be admitted into the particular course or not. Based on the information of the students, whether the candidate can be admitted into the group or not, we can predict. And based on the customer behavior, we can predict whether the customer will come back to or return to the shop again, or the candidate may not come to the shop again. We can predict. So based on the customer behavior information, we'll be able to predict whether the candidate will come or the candidate may not come. And then based on some attributes, the characteristic features of the interview, the candidate information, we can predict the candidate is successful or not successful in the interview. So the outcome variable is a dichotomous, binary, only two outcome, yes or no, or successful, not successful,
Yes, sir.
pass or failure, either the candidate will have the disease or may not have the disease. So this example we have been seeing with age, with gender. There are different type of diabetes level, controlled diabetic, no diabetic, uncontrolled level of diabetic, hypertension, and the level of whether the candidate is doing exercise, not doing exercise. Is it associated with the candidate into the hypercholesterol? So based on this age, based on the gender, whether the candidate is a diabetic or not diabetic, hypertension, and exercise, whether this variable is associated with classification of being the candidate as a hypercholesterol or not cholesterol, low cholesterol, hypercholesterol, low cholesterol. Can we predict? Can we predict? So that is a possibility we can predict. So impact of age on predicting the candidate in hypercholesterol or low cholesterol. So there are two categories, hypercholesterol and low cholesterol. So anything 6.3 and above is a hypercholesterol. Less than 6.2 millimole is a low cholesterol. So how age impact? 1 year age increases, how much likely the candidate being into the hypercholesterol? So when compared to female, how much risk male do have being into the hypercholesterol? Suppose someone is uncontrolled diabetic beyond, the candidate is taking medicine. How much likely if a candidate is uncontrolled diabetic level, how much risk he has being into the hypercholesterol? Or someone is doing exercise and another one is not doing. So someone is not doing exercise, how much risk he has being into the hypercholesterol when compared to someone is doing exercise? Understood? The risk we can predict, risk we can anticipate. Understood the participant? So we'll go one by one, and then we can also go for, suppose if you have one independent, one dependent. Independent variable can be numeric. Your independent variable also can be categorical. Independent variable also can be ordinal. Outcome variable definitely should be binary. Categorical only. Outcome variable, categorical, binary, dichotomous. So we can predict. So please open the file hypercholesterol. So the steps I will explain. Once you open the file, we need to go to analyze regression binary logistic. In this window, we have to keep hypercholesterol. This is in category. So there are two categories, hypercholesterol and low cholesterol. We need to keep the outcome variable, your dependent variable, categorical dependent variable. And then your independent variable, we need to keep it here. Independent variable, we need to keep it here. And then click option, we need to check the Hosmer Lame-Show goodness of it, chi-square. And then we also can click confidence interval. That's it, continue. Then click OK, you will get one output like this. So in this table, we are going to infer the results. So the exponential B, this value, we have to see whether this is significant or not. Age do have significantly influencing the differentiating the hypercholesterol, not hypercholesterol. So age significantly influencing or predicting a candidate being into the hypercholesterol, not into the hypercholesterol, significant, this p value. So how much risk the candidate has? So this we call them as odds ratio. So anything more than 1, this unit, the exponential B, anything more than 1, the candidate has got high risk. Anything lower than 1, we can call them as a lower risk. So this says that every 1 year increase in age, 1.2 times likelihood, more likely of having hypercholesterol. 1 year age, for example, your age is 30 years. Your age is 31. Someone is 30 years, and you have 31 years old. You have more 1.2 times more likely of having hypercholesterol compared to someone is 30 years old. Okay, so 1 year increases this much more likely being into hypercholesterol. Shall we run this system? Shall we run this particular?
So this odds ratio greater than 1 means at risk.
High risk. High risk, sir.
High risk.
1 means
and less than
no
less
risk.
than 1 means low risk.
Low risk. No, less
low.
risk. Low risk. Yeah, low risk.
Oh.
Okay. So how we can summarize the table? The table can be, you can summarize like this. So SPSS will give you a lot of information. When you go for research publication, journal publication, or a PhD thesis, we don't keep all the SPSS raw data. All the tables, we don't keep it. So we have to summarize in a scholarly way. In a professional way, we need to summarize the table like this. So this is easy to convince the audience, convince the reviewer. So the variable, and then less than how many candidate are there, more than how many candidate are there. And what is the average age of the less than 6.2 cholesterol level candidate? Standard deviation. What is the average? Say again, sir. Say again, sir. Please tell me, someone asked me some question. Someone asked me some question. I'll tell you how to calculate the average. I'll tell you how to calculate the average. Average standard deviation. And this is actually a crude odds ratio. Crude odds ratio. So this will explain 1 year age increases, 1.21 unit having more risk. And this is significant. This is significant. So these all values we need to capture from this table. Participant, someone audio is making noise. Someone audio making noise. Could you please stop your audio? Yeah, thank you. Thank you. Okay, shall we run this? Shall we run this? Do you get the similar results or not? Please go to the SPSS file.
Sir, I think yesterday we ran it.
Okay, just I'll demonstrate. We can move on, sir.
Okay. Yeah, yes, sir.
Okay, so participant, if not, shall we move on to the next exercise? If you have understood, then we move on to the next one. Anyone? Do you want me to repeat, or I will move on? No response?
Sir, it will be better if you repeat it.
Better? Shall
Yes,
I rerun?
sir.
Okay, okay. So please go to analyze. Please go to analyze. So please, you need to understand what condition this particular test will be applicable in your field of study. Think about it. Whenever you have your dependent variable, the dependent variable consists of only dichotomous. binary. Outcome is only 2. And you have couple of independent variables. Some are numeric, some are what you call ordinal, some are categorical. Predicting, you can go for binary logistic regression. I've given you a couple of examples also yesterday class. Okay, analyze regression. Can you please see there is a binary logistic regression? Binary logistic. Binary logistic. Just click on it. Just click on it. Do you have this window? Do you have this window?
Yes, sir. Yes.
So what do you need to do? You transfer your hypercholesterol into this dependent.
Yes, sir.
This is our last variable. So less than and greater than. Less than, more than 6.2. There are two categories of people. Anything more than 6.3 is a hypercholesterol. Anything less than, no cholesterol. So I have transferred. So we need to capture the age into the covariate. Age into the covariate. Click on option. In that, you please check only the Hosmer and the confidence interval is enough for a simple analysis. Hosmer, lame show, goodness of it, and then confidence interval for the exponential b slope. Continue. Click OK. You will get simple output. Please tell me whether you all got the output or not. Please tell me whether you all got the output or not. There are 200. Please tell me.
Yes, sir. Sir.
So the results show that 144 candidate are less than, 56 candidate or more than. But the total candidate 200. The total respondents in the study, the data collected is 200. So you don't need to worry about it. Please go to the last table. Please go to the last table, and the classification table and the variables in the equation. So this particular study, 74% accuracy. If someone having hypercholesterol or someone having not cholesterol, the model predict 74%. Predict 74%. Anything more than 70% prediction, the particular model is very good. Please take note. Anything 70% and above, the model is very good. We can use it for prediction. 70% and above in the classification table. So then we need to go to the variables and the equation for prediction. So this is significant. Age, 1 year age increases being into hypercholesterol. So age has got influence or impact on hypercholesterol. How much risk it has got? So 1 year age increases this much unit of likelihood or risk increasing. 1 year age increases, this much risk is increasing in the being into the hypercholesterol. So how we rely on this study? Look at the 95% confidence interval. So when you conduct the study for 100 candidate, 95 candidate, 95 times, or you repeat the study, your exponential will be from 1.12 to 1.30. 1.12 to 1.302. The likelihood for 1 year age increases, 95% of the time you may get the similar results with a confidence interval of 1.12 to 1.302. So this is what we need to write for the inference. Next one. So how do we, this is the way you need to summarize it. So we do not know the average age and number of candidates. Shall we calculate more than 62, how many, more than 6.3, how many candidates are there? Shall we calculate? Please go to analyze.
Yes.
Please go to analyze. Descriptive statistics, frequencies. Please go to descriptive statistics, frequencies. Please transfer your hypercholesterol here. We can also go for a chart, pie chart. So how many are hypercholesterol? How many are How many are less than 6.2? How many are more than 6.3? Pie chart, continue, click OK. So it shows that 144 candidate are 72%. Among the study, the respondents 72% are less than 6.2. 28% are more than 6.2. So this number can be captured in the table 72, 28. 72, 72%, 28%. But we are interested in what is the average age of the candidate less than 6.2 and more than 6.3. Shall we calculate the mean value and standard deviation? Shall we calculate the mean value and standard deviation?
Yes, sir.
Suppose in this graph, maybe you can double click. You can also include the percentage. Easy way. You can also include the percentage. Easy for you to present. So 72% and 28%. 56 and 144 candidate. Now, go to analyze. We are going to calculate the descriptive statistics. Descriptive, explore. So hypercholesterol should go into the factor. Age, you need to transfer them into dependent. Hypercholesterol in the factor, age in the dependent. Click statistics. By default, descriptive statistics have been chosen. Continue. So transfer age, hypercholesterol, just click OK. So you will get this table. So in this table, we can summarize it. You have a mean value. You have a standard deviation value, 38.31 and 4.834. Less than 6.2 category. So the average age of the candidate. More than 6.3, 42. Can you see the differences? Can you see the differences between 38.31 and 42? Age differences. So age increases, the cholesterol also increases. Being into the hypercholesterol is increasing. Agree? So this table and the frequency table need to be summarized like this. Should be summarized like this. Understood or not? Understood or not? Understood or not? So now the next
Yes,
example. The next example. So being into the diabetics, there are 3 levels of diabetic. Among the 200 candidates, some are what you call no diabetics, and some are controlled, some are uncontrolled diabetics. There are 3 group of people. So being into the diabetic, how the likelihood or risk having the hypercholesterol. Shall we move on? Go to the particular table. Go to analyze. Regression. Binary logistics. So what do? You remove the age. This time you transfer the diabetic. You remove the age and transfer the diabetic. Yes or no? Have you all transfer the block 1? Keep the hypercholesterol there and transfer the DM into this block. So this is a categorical. So click on the categorical. Do you have this window? Please tell me. When there is a categorical variable, you have to click. So in this, you have to transfer the DM into this categorical covariate. So in this DM, we have 3 group of people. No diabetic, uncontrolled diabetic, and controlled diabetic. 3 group of people. So what we need to do, click first. We are going to compare with someone is not diabetic and someone is uncontrolled and someone is having diabetic. So compared to control candidate or no diabetic candidate, how much risk they have. So our control group is no diabetic. So click on first and change. Click on first and change. You have to click first and then change the indicator. So the benchmark of comparison is no diabetic, no DM. Understood? Understood? Continue. Continue. That's then click OK. By option already been chosen. Hosmer and Lemshow and confidence interval have been chosen. Continue, then click OK. You will get. You'll get. Please go to the last table. So 73% it predicts. 73% predicts. Well and good, more than 70%. So this one is a control group. DM means this is called what you call no diabetic. This is for diabetic group. This is for uncontrolled diabetic, third group. So what inference we can make? What inference make? Anyone? Could you please tell me? Someone is a diabetic and another group is uncontrolled, means beyond the limit. So who is having more risk? How much risk is there when compared to no diabetic? Someone is diabetic, someone is no diabetic, and someone is uncontrolled diabetic. So using this exponential, how we can predict? How we can predict? How we can interpret the results? So this is the results. So this is the results. So DM is no diabetic. DM1 means is a diabetic. DM2 means uncontrolled diabetic. So controlled DM group have 1.874 times most likely of having hypercholesterol compared to other group. Controlled diabetic group, meaning they are maybe making exercise and diet. So they do have this much times more likely being into the hypercholesterol compared to other group. How about the uncontrolled group? They are not following the dieting, and also their diabetic level is very high. How much risk they have? They have 5.17 times higher risk when compared to normal. Agree? So this is what we need to infer. So how do you summarize it? This in the table like this. I will tell you the table later. I have given you that later. So this is what we need to capture in the results. So controlled DM group have 1.87 times most likely of having the hypercholesterol. Uncontrolled DM group have 5.17 times most likely of having hypercholesterol compared to other groups. The similar way, previously we saw it, right? The similar way we need to go for it. Maybe the table I have given somewhere there. Yeah. So the summary need to be presented like this. DM, no DM. There are 73 candidate, controlled 56 candidate, uncontrolled 15 candidate. This is a categorical data. So frequency only can be given. Less than, more than 6.3, 16 candidate, no DM, 23 candidate controlled diabetic, 17 candidate are uncontrolled. And this in parenthesis or in percentage. So this is actually is the adjusted the odds ratio we have to capture. And then this is actually confidence interval. And then we need to spell out the P less than 0.05. P less than 0.05. So similarly, you can conduct separately for exercise. Someone is doing exercise, someone is not doing exercise. How much risk he has. Okay. So maybe we'll take one more example. Let us see any other example I have. Yeah. Let's see any other example. Yeah. So imagine that this may be easy for you to understand. A pharmaceutical company developed a particular drug for women. So pharmaceutical company developed a drug, but when you take a drug, sometimes someone will have a reaction, adverse drug reaction, some allergic reaction. For your easy for you to understand, I'm giving you allergic reactions. So having allergic reaction, how does influenced by other variable? someone is, based on the systolic blood pressure, does it influences the drug reaction? Cholesterol level influences the drug reaction. Age of the person influences the drug reaction. Whether the candidate pregnant or not pregnant influences the drug reaction. So each independent variable, how is going to impact the drug reaction? We are going to anticipate. We are going to predict. So our dependent variable is they do develop a reaction and they do not develop the reaction. So they do develop reaction means we have classified as 1. No adverse reaction means 0. So this is your data. This is your data. So how many variables are there? There are 5 variables are there. Blood pressure, cholesterol, age recorded, pregnancy, whether the candidate pregnant or not, and then drug reactions. See the first candidate, 7th candidate, 120, his blood pressure, his cholesterol level is 180, his age is 59, not pregnant. Actually, all the data is belong to female, not pregnant, and not showing the reaction. How about the candidate number 11? Blood pressure is 135, cholesterol is 190, age 18, pregnant. So no reaction. Look at here another candidate number 16, row number 16. Blood pressure is 100, cholesterol is 180, and age is 21, pregnant, no. Candidate number 16, 100 systolic blood pressure, 160, 19, pregnant, and the candidate is showing the reaction. So how each variable influences being into the drug reaction. So how much risk blood pressure influences, how much cholesterol influences the reaction, how much age influences the reaction, how much pregnancy or not pregnancy influences the reaction. So you need to key in the data like this. Then we need to go for analysis the same way we did. I think we can move on. I will demonstrate. Please open the file. The data file is 1 minute. Which file is? Yeah, 2.5.2. 2.552. Participant, please delete the last 2 columns. Have you all opened the file?
Yes, sir.
The last 2 columns, just select and delete. I think I worked out clear. If you have it, just delete. Using your mouse, just select and delete. The same data I have presented just now. So drug reaction, actually, some are showing the reaction, some they do not showing the reactions. So we can predict, for example, one of your friend, you know his you know her blood pressure, you know her cholesterol, you know her age, you know whether she is pregnant or not. The candidate is going to take the drug, whether she will develop a reaction, whether the candidate may not develop a reaction, you can predict, you can anticipate, you can estimate in advance based on this data, based on this model. So that is what the application of the logistic regression. Whether the candidate develop a reaction or not, based on this model, the likelihood we can predict based on these 4 attributes, 4 characteristics, 4 features, 4 kind of variable, will be able to predict whether the candidate will develop a reaction for the particular drug or not. Understood the concept? Understood the concept?
Yes, sir. Yes, sir.
Shall we move on?
Yes, sir.
Go to analyze. Regression. Binary logistic. So drug reaction, we all have this window. We all have this window.
Yes, sir.
So what you need to do, you transfer the drug reaction into the dependent. So remaining all, you transfer it here. One minute. think the categorical we need to do it separately. I'm not mistaken. 1 minute. Yeah, no worry. So in this, we need to transfer all our variable. So click categorical. You press pregnant and click categorical. So pregnant, we need to transfer it here and click first and change. So among the variable, one variable is a categorical, nominal, pregnant or not pregnant. So that variable we need to classify. We need to specify in SPSS. So pregnant, you transfer it here, click first and change. Continue and then click OK. Sorry, option, click option. You click Hosmer, Lame, show goodness of it, and the confidence interval for the exponential. So how does each...
Sir, can you repeat the steps once again?
You missed, ma'am?
Sir, can you? I had a network.
Okay, from the beginning.
So somewhere I lost what you were saying in between after the drug reaction.
So from the beginning, do you want me to repeat or from this step?
From this step only, sir. From this step.
Okay. So you have you transferred all your covariate, all your independent blood pressure, cholesterol?
Yeah. Sure, sir. After this.
Dependent you have done. So once you are done, click pregnant. Click the variable in the covariate.
Okay.
Categorical. Click categorical. Click categorical. So this we need to transfer it. The pregnant you need to transfer from left side to right side. Have you done? Have you done?
Yes, sir. Yes, sir.
So once you're done,
sir. Yes, sir.
Then can you please see there is a first the reference category. So we are going to see not pregnant and pregnant. So pregnant women, how much risk he has, she is going to have when compared to not pregnant. So click change. Click first and change. Continue. Click change and continue. So that pregnant indicator first will be displayed here. Continue and then click option. Something is wrong. 1 minute. So click option, Hosmer and CI, confidence interval. Only 2, this is enough. Continue and OK. Continue and OK. So you may get a lot of table. Easy, you can go to the last 2 table is enough. Last 2 table is enough. So this is what we are going to go for in inference writing. This is for classification. How well it's predicted. Meaning 80% see the model drug reaction, someone is not having drug reaction, the model predict 80%. So for example, specificity, someone have the disease, someone really they have the disease, but the model predict exactly 86%. Someone do not have the reaction, the model predict 73%. Sensitivity and specificity, and this is for 80% accuracy. So for us, anything 0.7 and so 70% is well and good. 70% is well and good. Okay, so maybe the inference writing, how you can go, I will explain you here. So this is what the inference you need to write. The classification table shows that the model makes a correct prediction 80% of the time overall, 85% accuracy. So there are 15 women in that study. They do not have the drug reaction. First 15%. So the model predicted 11 of them. In reality, they do not have, but it predicted 11 correctly. But the model predicted some they do not have the drug reaction. The model predicted 4. So 73% only sensitivity. But another case, 15 candidates, they have the drug reaction. Among them, 13, the model predicted, yes, they have the reaction. 2, they do not. So it says that 86% correctly predicted. 86% correctly predicted. So overall 80%. Overall 80%. So the average of the two. So average of the two is 80% overall percentage. Right? So the model is very good. We can use this model for prediction. So the next table we need to we need to go for it. How do we? So since the blood pressure and cholesterol show up here, not significant, but the sample size is very, very less. So in we don't need to consider whether this p-value all the time significantly. You don't need to worry about it. When sample size is very big, you can seriously consider. Sample size only 30, so we can proceed with whatever the exponential we have. So blood pressure, low likelihood, less than 1. One unit of cholesterol increases. This much unit, 1.026 unit, the higher likelihood being into the drug, showing the drug reaction. 1 year age increases, 1.282 times more likelihood. 1 year age increases, 1.282 times more likelihood the candidate having more risk to show the reaction for the particular drug. Being into the what you call the pregnancy, so risk, can you please see the risk very, very high? Can you please see the risk is very, very the high when compared to someone is not what you call pregnant. This much risk someone is when there are pregnancy, so this much higher likelihood they be into the risk. So, but for equation prediction, whether the candidate really will have the drug, what you call the reaction or not, we can form this equation. So log odds of the reaction to drug. So this is a constant. So same thing we have used for multiple regression. Say so no, multiple regression also we use, right? The same equation we can use it. So constant plus the blood pressure. You can, for example, you have one of your friend, how much blood pressure she has, put her blood pressure here. And how much she has a cholesterol, you put the cholesterol value here. And what is her age, you keep the age here. Whether your friend is pregnant or not, you put yes or no. And then you come to know, finally you come to know the one value. With that value, we can anticipate whether the candidate will develop a drug reaction or will not have the drug reaction. We can predict. Yes or no? So substitute this value, you come to know. Any regression, the positive coefficient indicate a positive relationship. Agree? Agree? So this is what the logistic regression can be predicted. So interpretation you can write like this. As an illustration for computation purpose, we are going to predict the probability. For example, someone blood pressure is 140, cholesterol is 170, age is 73, and something's wrong, not pregnant. This is not pregnant. Not this is the candidate is not pregnant. Whether the candidate do develop the risk or not, do develop the drug reaction or not. So just we substitute the value. So maybe you can please tell me whether do you get this answer or not? Whether do you get the answer or not? Maybe what do you do? We can copy this value, put Excel. Otherwise, simple, I will copy the table easy. Copy the table easy. I hope everyone would got the answer. Copy the table easy. Please tell me, have you got the answer or not? One minute. Let me open the Excel file. So please copy and paste the table. Participant, please copy and paste the table, the equation table.
Yes,
So these all values.
we have done it.
Okay, this value we need to capture it somewhere here. Easy. So what age group we have? 140. 140. This is what the value. 140, 170, 73, and 0. So blood pressure is 140. Cholesterol is 170. What is her age? Age is 73. And the candidate is not pregnant, 0. And this is a constant. So we can multiply this into this, and then you can drag down. Finally, we can calculate. Finally, you can calculate. So this value,
Yes.
this plus this plus this plus this. We'll come to know
The
the value.
age is 73.
Ah, yes, 73, ma'am. Yeah, 73. The data collected, the study collected. Just imagine that. So whether the candidate will develop a drug reaction or not. So 3.26, the value. So what we need to do, there is a formula for this. This is a formula. The predicted probability. This is the probability. So exponential B, this is exponential value. This is exponential value. So we can predict. Equal to, just put exp, exponential. This value, formula, yeah, divide by bracket 1 plus put exp, exponential, this value, close the bracket. So you come to know one property, one value. Please tell me whether you got the answer. Please tell me the answer. So anything more than 0.5, the value that we calculated, the probability. The candidate will show drug reaction. Will show the drug reaction. Yes or no? Have you got it? So this is more than 0.5. So the candidate definitely will have, based on the age, based on the cholesterol, and not pregnancy, whether the candidate will develop a drug reaction or not, this particular female will develop a reaction. Anything 0.5 and above, consider show the reaction. Agreed? I hope you would have understood the concept for binary logistic regression. This way you can predict whether the candidate will develop or may not develop. Okay.
Sir, how did you get this 0.96? Sir, how did you get this 0.96?
We have to go for exponential. This actually is an exponential value.
Yeah.
Oh,
So
got it.
One.
That's
Okay.
it's fine.
So this is a formula. Maybe you can take note. Exponential, this value divide by 1 plus exponential, that value you will get this thing.
I'll do it.
Okay. So we also can come to know the value. Maybe what do you do, ma'am? Go to logistic regression, same. Go to analyze. Analyze regression. Binary logistic. in the option, could you please select case-wise listing of residuals? Case-wise classification plot. And then continue, click, save. And you please see here the predicted value and the group membership. Participant, could you please select in the save option? In the save option, could you please select the probability and group membership? Please tell me, you'll get one table. Okay, continue.
Yes, sir.
Continue, and then click OK. So,
Sir, can you repeat, sir?
Okay. Go to analyze, regression,
Yes, sir.
binary. In that, you need to click save, sir. In that, click save.
Okay.
Probability and
means
group membership.
yeah, previous one only. We need to go to save.
Yes. Save. Click the first two.
Yes.
Probability and group membership.
Okay.
And group membership. So the system will give you whether the candidate, based on the probability, will have the risk or may not have the reaction. Continue and OK, sir. Continue and
no
OK.
need to go for this case-wise study, sir. Where is the case-wise study?
Not needed, sir. Not needed. Just click OK. This is enough. The probability.
Okay.
So you will have one table. It's not showing.
Last table, sir.
Sorry.
Equation, sir.
The table will be there. Sorry, your table will be here. The table will be here. The predicted membership you asked, right?
Case process.
Yeah, case processing. This one. Can you please go to your raw data?
Yes, sir.
Okay.
Analyze.
So, can you please see this value? 0.977. The candidate will have the predicted membership. The candidate will have the drug reaction. This is what we predicted. So age, blood pressure is 140, cholesterol is 190. This particular value, based on the equation, we predicted the probability is 0.9777. And the candidate will develop drug reaction. So the same value we got it. Yes or no?
Yes.
I think age is
yeah.
Cholesterol is 190.
Last value.
Participant, please put cholesterol is 190. Please put cholesterol is 190. Can you please see the value?
Okay.
The same.
Just
this is the probability.
Okay. In place of 170, if we 170 will be replaced by 190.
190. Okay. So this is based on the equation we predicted. This is based on the model the system suggested. 140 blood pressure, 190 cholesterol, is her age is 73, not pregnant, and the candidate really showing the drug reaction. Model also predicting the candidate is showing the reaction. So this is what originally the data we collected. While analyzing the data also show that yes, this candidate will definitely show the reaction. Yes or no?
Yes, sir.
I think
we are all.
Yeah, understood means fantastic. So think about it where this will be useful. So I have given you the interpretation also. Actually, I do not have any examples for business related. So I tried, but actually my area of research is biotechnology. But I didn't expect this logistic regression and factor analysis. So somehow I have convinced giving you some simple example and the interpretation also given. Okay. Yeah. So I have remaining two topics.
So, one question over here. In industry, what kind of in organization, if I talk from the management perspective, what kind of situation will this be useful?
Ma'am, in an organization, you are conducting an interview. You are conducting interview for your students. you are going to
Yeah,
recruit
like
someone.
when we are trying for marketing.
Yes, or any product
Yes.
sales, and then the customer behavior can be based on the student attribute. The student can be enrolled for your what you call your master's MBA program based on his undergraduate GPA and his test mark, and his what you call your 12th standard or some English language test, whatever. So based on this, the candidate can be admitted or cannot be admitted. You can go for it. That application also you can use it.
Good, sir.
So based on the previous data,
Thank you so much, sir.
just you plug in the value of the particular present candidate. So the system will give you, okay, anything more than 0.5, the candidate can be successful, can be admitted. Anything less than that, you need to think, not successful. Okay, yeah.
Fine. Thank you so much, sir.
Okay. So I will go for factor analysis. Then last one is a cluster analysis. So I hope this will be useful. Factor analysis. Factor analysis
Yes,
actually
sir.
factor analysis actually is a multivariate analysis, multivariate technique, statistical technique used to identify the underlying by means of clubbing related variables in the same factor. For example, when you conduct a survey related research, I'll give you a simple example. You are interested in assessing the job satisfaction of your employees. Job satisfaction. So instead of asking directly whether are you happy or not, you give some kind of around 10 items. Indirectly, we assess the satisfaction. So you plan 10 items. Otherwise, we call them as 10 variables or 10 indicators. The 10 indicators used for predicting the satisfaction of the employees. So how well your indicator is going to predict the job satisfaction, your intention. Job satisfaction actually is the intention. So how well your items, how well your indicators is able to predict the job satisfaction, how well they are correlated. All the 10 items, all the 10 indicators, how well they are correlated. So factor analysis is based on correlation. Highly correlated variables are clubbed together. Highly correlated variables are go together. And the uncorrelated variable will be in another factor. So I'll give you one or two examples so that you will understand the concept of factor analysis. So there are two types of factor analysis. One is exploratory factor analysis. Another one is a confirmatory factor analysis. So when do we use exploratory? When do we use confirmatory? Exploratory means you have some objective, but in theory, you do not have any idea. In theory, you do not have any idea, but just you collected some items, 10 items for job satisfaction. You may not, all the 10 items may not correlate. You are interested in, among the 10 items, so we are going to reduce for 2 items or 3 items. Just we call them as exploratory. You do not have any idea. You have constructed the items and indicators going to study about the job satisfaction. Is called exploratory factor analysis. Confirmatory means you have some theory, you have some instrument, or you are going to use the instrument already tested, already validated by somebody else. You are going to use it. How confirm the particular item is conforming with the previous study. How well your study conforming with the questions you adapted from someone else is called confirmatory factor analysis. Is it true or is it deviated from the theory? We can go for it.
Sir, can you repeat CFA, please?
CFA means, ma'am, already you have some idea, you have some theory, or you have some validated questionnaire. Somebody else done it. But in Indian context, you wanted to repeat the study. Got it? Got it? So you are you have adapted someone questionnaire. You wanted to try in our context. So how well in Indian context, how well all the items you adapted in the questionnaire predicting the factor. Okay. Exploratory means you do not have any idea, just you are going to explore how many factors are available.
So sir, in that case, EFA can be run only when we construct our own questionnaire, and CFA can be run on the already tested questionnaires.
Fantastic, ma'am. Fantastic. Fantastic. So factor
Sir,
analysis. Say again, ma'am.
Sir, please exploratory one once again.
Exploratory, ma'am, you do not have any idea about it, about the nature of the study. But you have objective, you have hypothesis. Job satisfaction, you are latent variable. But to study the job satisfaction, you and your friends and your supervisor discussed what are the variable can be included to assess the job satisfaction. You and your students and your your colleagues, you are going to propose 10 items to assess the job satisfaction. So how well the 10 items or 15 items indicator, the variable is going to predict the job satisfaction. How well the variables are correlated. So how many factors can be formed within the 10 variables? 10 indicators variable. Understood or not? I'll come back to you, ma'am. I'll come back to you. The one or two examples so that you will clear.
Excuse me, sir.
Yes.
Sir, you mean to say those variables should be indicator of another dependent variable,
Yeah.
or those are to be correlated with each other?
Yes. So among the 10 variables, some variable go together, some variable maybe rest of the variable in another factor. So we can rename it. I'll come back to you one or two examples.
Can we do it with secondary data also?
Secondary data also can be, ma'am.
Okay. Thank you.
Yeah. So factor analysis is used to find factors among observed variable. If your data contains many variable, you can reduce them into fewer. Let's say you have 20 indicators regarding job satisfaction. So 20 can be reduced into few. Maybe what are the factors normally the employees will be happy? What are the factors, ma'am? For example, what are the questions normally?
The salary, work
Fantastic.
environment.
Work environment.
Then teammates,
Yeah.
relationship.
Okay.
And
so
team leader.
Yeah, these are
bonuses and
bonus,
incentives.
whatever. So these all overall. So to understand this, you ask them some questions: salary, environment, the co-workers, colleagues, ambience, facilities, bonus. So combine all of them in 20 questions. So how well later on we can classify them into salary and bonus and the co-workers, we can group them. So 20 variables can be grouped into 4 factors or 3 factors. So 20 factors, 20 variables can be grouped into 3 factors or 4 factors, reducing them. So that is called dimension reduction. So factor analysis, you can produce a small number of factors from large number of variables, large number of indicators, and capable of explaining the observed variance in the larger number of variables. So instead of study 20 items, you can go for 3 factors. Let us see. So factor analysis helps the researcher to reduce the number of variables to be analyzed, thereby making the analysis easier. Consider a market researcher at a credit card company who wants to evaluate the credit card usage and behavior of customers using variables. The variables include age, gender, marital status, income level, education, employment status, credit history, family background. So analysis based on a wide range of variables can be tedious and time consuming. So using factor analysis, we can reduce large number of variables into few dimensions called factors that summarize the available data. So it aims at grouping the original input variables into factors which underline the input variables. For example, age, gender, marital status can be combined under factor. We call them as a demographic characteristics. Income, education, employment can be combined under the factor called socioeconomic status. And the credit card and family background can be combined under the factor called background status. So based on the larger set of items can be grouped into later on few factors. The factors can be renamed. So don't worry, we have a couple of exercises I'm going to demonstrate. So what are the assumptions? Assumption, you need to have multiple variables. So the variables can be continuous or the variables can be ordinal. And then second assumption, the variables, continuous variable should have a linear relationship. A variable should have a linear relationship. This can be assessed by the Pearson correlation. And then the sample should be adequate. Sample should be adequate. For example, some people say that, so let's say you have 10 variable, you have to have 100 observations, 100 respondents, the data is to be collected. Some people say that 6 is enough, for each variable. Let's say you have 10 variable in your study. So the 10 variable multiply with the 10 numbers. So 100 candidate, the data to be collected for the study to have the valid results. So we can also assess the sampling adequacy, whether the sampling is adequate to predict, go for a dimension reduction, conducting factor analysis. And then there should not be no significant outliers. There should be no significant outliers. So these are some basic assumptions to run the factor analysis. So what is the difference between exploratory factor analysis and confirmatory factor analysis? Exploratory factor analysis, the data is simply explored and provide information about the number of factors required to represent the data. In exploratory factor analysis, all measured variables are related to every latent variables. Whereas in the confirmatory factor analysis, researcher can specify the number of factors required. You can mention, I expect this many factors in the data. Based on the previous study, you are going to go right, confirmatory. Suppose you have 4 factors or 5 factors. You can specify. So this many factors, whether all of them go together. So confirmatory factor analysis is a tool used to confirm or reject a measurement theory or model or hypothesis or some idea, confirming the hypothesis. Okay, let us see. So when is factor analysis applied? You may be interested to investigate the reasons why customers buy a product, such a particular brand of soft drink, for example, Coca-Cola. Several variables were identified that influence a customer to buy Coca-Cola. Some of the variables are identified as influential include cost of the product, quality of the product, availability of the product, quantity of the product, the respectability of the product, prestige attached to the product, experience with the product, and popularity of the product. So these are the items. So from these items, we can combine them, we can put them into 2 or 3 factors. So all the items are from 1 to 7, Likert scale. Important to very important. Not important to very important, Likert scale. 1 to 7 or 1 to 5. We can go for Likert scale study. So another example. Yep, this is actually I took from one of the textbook. A private domestic airline operators raised their airfare in December 2000. Indian Airlines, the government-owned carrier, was the only domestic airline which did not follow the suit. Information available from the particular magazine showed that people still prefer to fly Jet Airways. The reason for the above preference had to be ascertained as according to Indian Airlines, official domestic flyers are price-conscious customers. So, this study, they have recruited 20 respondents. So they have recently flown with Jet Airways. They prefer Jet Airways. Why? They have chosen the Jet Airways. So to study that, they were asked to indicate 7-point Likert scale questions. Completely agree to completely disagree. These are the 10 items were asked. These are the 10 items were asked among those who were flown with the Jet Airways. 20 respondents, 10 items. So the Jet Airways are always on time. Seats are very comfortable. I love the food they provide. The air hostess are very beautiful. My boss and friend flies with the same airline. Airlines have younger aircrafts. I get the advantage of frequent flyer program. The flight timing suits my schedule. My mom feels safe when I fly Jet Airways. Flying jet complements my lifestyle and social standing in the society. So these are the statement you have given to the customer, those who have flown on the particular Jet Airways. So these 10 items can be combined up, can be clustered, can be factored them. Okay, so imagine that this is the data. There are 20 respondents, 10 items: on time, comfort, food, hostess, boss, airing, frequency fly, schedule, mom, and lifestyle. So each one items, 10 items. This is 10 items. What did participant? 10 items. We are going to reduce them into 10 into 2 or 3 factors. So we need to key in the data in SPSS like this. Like this, we need to key in. And then we need to run the analysis. I'll come back to you. I will explain how to interpret the results. Shall we proceed? Shall we proceed? Please go to the folder. Please go to the folder. File name is 1 minute. Yeah, 3.1.1 factor analysis airline data. 3.1.1 factor analysis airline data. So there are 20 respondents. So 1 to 7, the rating, 1 to 7 rating, the 10 items, 10 statement. So the 10 statement, we are going to reduce them into few statements. So if any items highly correlated, they go together. They go together. We do not have any idea. So what are the variable? They go together, we do not know. But we are going to reduce them into 10 items. So when you conduct the next time, maybe this all can be reduced into two factors or 3 factors. How this can be? The next time when you conduct a study, the factors only can be asked instead of asking 10 questions. Next time when you conduct a study, only 2 factors can be asked. How do you feel? Something, comfort, whatever. Shall we move on?
Yes,
I will
sir.
open the file. Okay. Go to analyze. Go to analyze. Can you please see next to classify dimension reduction? Dimension reduction. Factor.
Yes, sir.
Factor. Very, very simple. What you need to do, you need to transfer all the 10 items here from left side to the right side, except the serial number. Except serial number, you transfer all of them. In a simple study, 10 items were asked among the people, those who have recently flown with the Jet Airways, and asked a couple of questions and their opinion, why they prefer Jet Airways. And can we reduce them, the 10 items, into some factors? So click descriptive. Click descriptive. Please check univariate descriptive. And then coefficient and KMO parallel test. Participant. Univariate descriptive, coefficient, KMO parallel test. Aspecificity. This is used for sampling adequacy, whether the 20 is enough for go for a factor reduction or dimension reduction or factor analysis. The 20 sample is it enough? So this is actually a hypothetical data. I have took it from one of the I think marketing related textbook. Continue. Please go to the extraction. We can ask for script plot. Very commonly used one is the principal components. So this system actually will predict based on the eigenvalue. Anything greater than 1, those variables are clubbed together. So those variables will be clubbed together. Anything more than eigenvalue 1 will be clubbed together. So only the script plot we have asked for it. The script plot, graphically we come to know how many factor have been extracted. We come to know from the script plot. Continue. Click rotation. Varimax very commonly used. In what you call in business related research. Continue. Then click score. Score, I think we don't need to do anything. Just leave it. Click option. In this option, please click suppress small coefficient. Some researcher, they go for the factor loading. Anything less than 0.4, you do not consider for factor reduction. Some they state 0.5 and above. Some say 0.4 and above, please include them. Some they say 0.5 and above, you include them. Less than that, you don't include them for factor reduction, any factor loading. So please put 0.4 absolute value, suppress the small coefficient. So any variable less than the factor loading 4 will not be included for factor reduction. Is that okay? Have you all done it? Suppress small coefficient 0.4.
Yes, sir. Yes.
Click continue. Click continue, then OK. Click continue and OK. Please tell me whether you all got the output.
Yes, sir.
The first table says that the average of the mean of the 20 candidate for the first each item. So the Likert scale 1 to 7. The Likert scale 1 to 7. What is the average? An average. So 2.1 standard deviation. So this is for you to highlight the numerical summary or descriptive statistics. So this table you can include in the report. The next one is a correlation matrix. How well each items are correlated with one another. So supposed to be the correlation should be each variable need to be related with one another significantly. For example, if any variables are significant with one another, they are highly correlated. They can be in one factor. Looks like, see here, the Jet Airways are always on time, related with I love the food they provide, significantly, highly correlated. Look at this variable. So Jet Airways are on time. This I love the food, and the airlines have younger aircrafts. These two items are code together. They code together. One can be one factor. The seats are very comfortable. Can you see any other correlation very high? The flight suits by schedule. These two are highly correlated. These two variables. So highly correlated variable, they will be in one particular factor. Understood? Understood, participant? So then we have to look at this KMO parallel test. The two assumptions we are going to test, whether the 20 respondents we have collected the data, is it sufficient to conduct a factor analysis? Usually 0.5 and above, the sampling is adequate. Some journal, some researcher, they used to say 0.6 and above. Some they go for 0.5 and above. Well and good. So 0.5 and above, the value of KMO parallel test, sorry, KMO is well and good. The model or the factor analysis can be conducted. And then the parallel test of sphericity, meaning, so this used to interpret how each variables are related. Are they correlated each other? So all the variables are correlated each other. This is significant. So value, if for example, you take value greater than 0.05, meaning some of the variables are not correlated. So we cannot conduct factor analysis. So this should be greater than 0.5. This should be less than 0.05. Understood or not? Understood or not? Say yes or no, participant?
Yes, sir.
So this should be 0.5 and above. This should be significant. Less than 0.05.
Sir, please, if you can repeat parallel test again, please. The
inference, ma'am?
Yes, sir.
Inference. So parallel test is meant for how well the variables are related one another. So null hypothesis say that the variables are not related. All the 10 items are not related with the rest of the items, each other. So the results show that actually one of the assumption, right? All the variables should be correlated. The correlation of each item with other item should be there. So the results show that all the items, all the variables are related with one another. There is a relationship. There is a relationship, meaning otherwise the relationship is greater than 0. The relationship is greater than 0. So all the variables are related. That's a correlation. So parallel test specify there is a relationship exists between the all the 10 items.
So parallel test, in parallel test is showing significance level 0.000.
Yes,
so how we can,
when there is a significant means all the variables are related.
Okay, that's what
all the variables are related. Yeah.
Okay, fine.
So for example, if variables are not related, you may get if your p-value, the significance value greater than 0.05.
Okay.
So here the variables are significant. So the Kaiser-Meyer alkene measure is meant for whether the 20 respondent is it enough for factor reduction. So this hypothetical data, the 20 respondents data is enough for factor reduction to conduct the factor analysis. Is that okay? This should be the cutoff point. The cutoff point 0.5 and above. This should be less than 0.05. The condition to assume the factor analysis to be conducted. If any one is violated, you can stop it here. You have to go for rerun the study. Okay. So next one is a communalities. Communalities means how well each items is loaded with a particular factor. Otherwise, how each items explains the factor. Otherwise, how the factor and the items are extracted. So this is called communalities. Otherwise, we can call them as a regression coefficient or coefficient of determination. We call them as a coefficient of determination, meaning the jet airways are always on R square value. R square value. So this is R square values, but in a factor analysis it comes with the communalities. So 93% of the variance of this jet airways on time can be attributed for factor extraction. The seats are always uncomfortable, 93%. 83% of the variance you see in the data, I love the food they provide, is used for prediction. So all of them are more than, except only one question. My boss and friend is with the same airline. Only this has got very less, 46% at the R square value. The rest everything is more than that. I think another one also. The last one also very less. The last one. My mom feels safe when I fly jet. So let us see. So there are three components can be extracted. There are three components extracted. What are the components? All the three components, anything more than eigenvalue greater than 1. So remaining all next to 4, after the 4, eigenvalue less than 1. So there are three components. Meaning the first component explains 31.31%. The first component, the items explain 31.7. First component may be for some variables. Second component explain 30%. Third component explain 18%. 18%. Right? So this is what the variance explained by each factor, each items in the factor on the particular factor. So there are three. So collectively, all the three factors, for example, 80%, the variance you see in the items explained by the factors. 80% is well and good. So anything 60% and above, the cumulative loading is well and good. 80% and above. Okay. So see, this is a graphically. We can see how many factors are there above one eigenvalue 1. So factor 1, factor 2, and factor 3. The 4 factor onwards, all are below the eigenvalue 1. So it's not considered for factor reduction. So look at the component matrix. What are the variables are comes under factor 1? How many variables are comes under factor 2? How many factors are comes under factor 3? So there are 3 components. Among the 10 variables are split into 3. So can you please see here? The seats are very comfortable. The jet airways are always on time in the second component. Second factor, I love the food they provide. Second component. My boss and friend flies with the same airline. Second component. The airlines have younger aircrafts. Second component. So these 4 items are in the second component. So we need to find out one name collectively to explain the 4 items. What name we can give it actually? Jet airways always on time. I love the food they provide. And boss and friend fly with the same. And then airlines have younger aircraft.
Services.
The
airline service that they provide.
Airline services you can give it. So this also the factor name, it can vary from your notion and with someone else. So we need to rename it collectively one name. So all the 4 items, they go correlated together. And then
that we can take from literature review also.
Yes, ma'am. Yes, ma'am. So for example, the seats are very comfortable. For example, this particular item loaded in component 1, loaded in component 3. So you can ignore the lowest loading. You can take the highest loading. So the seats are very comfortable. It loaded in the third component. The timing suits my schedule or in the third component. So see here, the item number 8 also cross loading. We call them as a cross loading. This particular item loaded in component 1, factor 1, and also loaded in factor 3. So you can remove the smallest one, you can retain the highest one. Understood? Understood? So the rotated component matrix only we will be using for interpretation. What are the items are loaded together? Item number 1, item number 3, and variable number 5 and 6, they loaded together. They loaded together. And then item number 4, item number 6, and item number 10 loaded together. And then item number 2 and the variable number 8, they loaded together. So this variable we need to rename it. Let us go to the data file, sorry, the slides, how the data were interpreted. This is what the inference can be written. The first output, the descriptive statistics table. This is what the table presents you, the mean standard deviation and the number of respondents who participated in the study. The mean standard deviation and the number of respondents participated in the study. And then second one actually is the correlation matrix. How well each variable are correlated with each other. So how well each items are correlated with one another, right? And then this is for parallel test, KMO and parallel test. And this is what inference you need to write. KMO and parallel test measure the strength of the relationship among the variables. The KMO measures the sampling adequacy, which determine if the responses given with the sample are adequate or not. We should be close to 0.5 for satisfactory factor analysis to proceed further. So as per the Kaiser 1974, recommend 0.7 value for KMO as a minimum barely accepted. And values between 0.7 and 8 acceptable, and values above 0 are super. You can use this terminology for explaining the KMO test, sampling adequacy. So looking at the table above, KMO measures 0.18, which is above the 0.5, and therefore this can be accepted. The sampling is adequate for running or conducting factor analysis. And the next one, the parallel test, how do we interpret? So parallel test is another indication of the strength of the relationship among variables. The test, the null hypothesis that the correlation matrix is an identity matrix. So identity matrix is a matrix in which all of the diagonal elements in the coefficient matrix and all of the off diagonal elements are close to 0. Null hypothesis states that so all the diagonal, off diagonal elements are 0, but alternate hypothesis not equal to 0. So if you want to reject the null hypothesis, your significant value in the table should be less than 0.05. So this says that all the variables are related. The correlation coefficient value greater than 0. The correlation coefficient for each variables related with one another greater than 0. So the variables are the variables are correlated, are related with each other. So this is what we need to write. And then communalities table. So what inference you can write for the communalities? So the communality value, which should be more than 0.5 to be considered for further analysis. 0.5 to be considered for further analysis. So else these variables are to be removed from the further steps for factor analysis. So in the variable has been accounted for by the extracted factors. For instance, the first item, 93.3% of the variance in on time is accounted for, while 46.2% of the variance in bars and French flies is accounted for the factor analysis, factor analysis, or constructing a factor. So each variable we need to spell out. Each variable we need to spell out for the communalities. And then this is for total variance explained. 80.72% of the variance can be attributed by having the 3 factors. Remaining 20%, some other we do not know. So 80% of the variance can be explained by the 3 factors which we have reduced into by having that. So this is all some definition for you to read. I'm not going to go each. And then scatter plot is meant for, discrete plot is meant for how many factors are retained. We have 10 factors, only 3 factors are constructed. Okay. So component matrix. This is what we need to write. So what are the items are work together? What are the items are moving together? Say here, interpretation. As evident from the table, looking at the cumulative factor, 80.7% of the total variance in this table, or explaining the three factors among the 10 variables. Sorry. Among the 10 variables, the three factor extracted 80.7% of the total variance. So hence we have reduced the 10 variables into three underlying factors. The three underlying factors we have to name it. How do we name it? We look at the items. So airlines have younger aircraft. They are always on time. I love the food they provided. My boss and friends fly with the same. So these can be from 0.959 to 0.578. They go together. They load together. So these four variables, we can call them as a customer service. Therefore, this factor can be represented as a customer service. Then look at the second column. I get the advantage of frequent flyer program. The air hostess are very beautiful. The flying jet complements my lifestyle and social standing in the society. So these three go together. So we can call them as a what we call benefits or incentive or kind of compliment they provide. You can rename it. And then factor 3, the last two items, seats are very comfortable and it suits my schedule. So this we can rename as a convenience. So the 10 variables, we reduce them into three latent factors: customer service, flyer incentive factor, and then convenience. So this is actually always subjective, depends upon the researcher. So interpretation, you conduct the factor analysis, you provide the factor, then we need to go for writing this in inference. Maybe I will explain how you can interpret the table also. In the SPSS participant, I will demonstrate one more easily. Now all the items are jumbled, right? Now we can suppress the what you call the factor loading, so that the first items will come together. Go to analyze participant, analyze, go to analyze, dimension reduction. Only one step we need to modify. Factor. Can you please see the option? In that you can specify sorted by size, so that all the items based on the particular factor, based on the factor loading, items are some what you call arranged accordingly, sorted by size of the factor loading. Continue, and then okay. Now you look at the last table.
Excuse me, sir.
Yeah.
Sir, what about the various options say under rotation? Promax, Verimax, what are the use?
All our options have different approaches. Sometimes it depends upon the prediction map. So very commonly used one is Verimax. When there is a highly correlated variable, will be predicted exactly, and low correlated variable also predicted accordingly. So Verimax is most common. The rotation method, very common method used in. So in each and every, the rotation method has got merits and demerits. Okay, so click the particular table, the rotated component matrix. Go to Excel. You can paste it. So what do? You can factor name it. This is a factors. So this can be in one factor. I will copy it. I'm adjusting the line width. So these all one factor. Factor one, customer service. We need to modify the table. And then next 3 is this is factor 2. This is factor 2. Time incentive or rewards. You can also go for rewards. Rewards also can. It's up to you. And the last one. What is that one? Last one is convenience, is it? Last one, convenience. Yeah, correct. So last one, convenience. Factor 3. So this is exploratory factor analysis. Convenience. Understood? Understood?
Sir, why we have to report rotated component matrix, not that component matrix only, principal component analysis?
This is actually the what call each variables are related with one another, and the highly correlated one will go together. These 4 items, they are highly correlated one another, and these are correlated one another, and these are correlated together. So highly correlated variables are in one particular factor. So based on the correlation, we are segregating items. And based on the items, we are going to rename the factor. So 10 items reduced into 3 items, 3 factors, 3 component: customer service, rewards, and convenience. Okay. So run out of time.
Sir,
yeah, please.
Sir, in the first table, component matrix table, there is also showing the same type of result, like 3
same
components.
Type of results, ma'am. Same type of results, but in factor dimension reduction, this is somewhat very organized when compared to other one. Rotated component matrix.
But sir, here in component matrix, the last 2, it is there are 2 in under 1. There are showing the seats are very compatible 0.40, 0.48.
Actually,
and the third component.
1 minute, ma'am. The component matrix, there will be cross loading.
Yes, sir.
Component matrix, there will be cross loading, whereas in the rotated component matrix, the cross loadings are removed. Instead of you remove manually, the rotated component matrix more convenient, ma'am. Easy. Okay.
But it means it is displaying the more appropriate.
So usually for interpretation, we use a rotated component matrix. Okay. So due to time constraints, I'm going to skip cluster analysis.
Excuse me, sir.
Yep.
Sir, in component matrix, if there is a negative value, then what we will do?
Negative value also can be included, sir. We don't need to worry about the positive or negative.
So suppose one like.
Okay. We can include them, sir. We don't need to worry about the positive or negative for. Acceptable, sir. Yeah.
Okay. Thank you, sir.
Acceptable. Yeah. So I'm going to go for cluster analysis. Time is limited.
Sir, with the CFA, we'll run the same test.
Same method, ma'am. Same method. Same way you can run. Yeah, same way you can run.
Okay.
And
so maybe if we are using multiple scales, then for each scale we have to run the entire, the test.
Yes, you are right.
For the dimension reduction, we have to run individually for each.
No, ma'am, you can put together. Confirmatory, you can put together, ma'am.
No, if I'm using 4 scales or 5 scales, standard scales, then we have to go, one by one, or we can club it together and run the test.
Club it together, ma'am. Run the test. Club it together.
Hello, sir. Sir, excuse me, sir. Sir, suppose in the questionnaire there are different types of questions, and for each question, several variables are also included. In
Okay.
that case, can we go for a separate factor analysis for each of the questions?
Actually, sir, exploratory factor analysis, you proceed with each what you call dimension separately.
Yes, sir.
Whereas in the confirmatory factor analysis, you can go together. You're going to confirm. Confirmatory, you can go together. All the dimension you can keep it together. Whereas exploratory factor analysis, each dimension you run separately, sir.
No, sir, I'm talking about for example, I'm using 4 standard tests. For example, one is job satisfaction, other is organizational commitment. For job satisfaction, I'll be using, doing the KMO separately, and for the organizational commitment, separately. For all the dimensions. Maybe there is 10.
Yes, ma'am. Exploratory analysis, yes, ma'am. Exploratory factor analysis. Exploratory factor analysis, all the dimension, the KMO, this thing separately need to be presented.
And with CFA, I can go, club together both the test and run.
Yes, ma'am.
You mean to say that?
Yes,
sir,
yes,
but
you're right.
In that case, the correlation table will be. Will that be correlated, because these are all different items? Maybe 10 items in job satisfaction.
Actually,
and
some items, for example, ma'am, some items if job satisfaction may be also related with organizational commitment. So those items need to be removed in the confirmatory.
Okay, all right.
Okay. Okay.
Sir,
So
excuse me, please. Sir, excuse me, please. Sir, I have only one question here.
Yeah.
Sir, many times I have done this factor analysis because I deal with multivariate statistics frequently. Sir, by which option those cumulativities that comes, and many times I fail to get that.
Communalities actually is meant for R square, sir. R square value.
Yes, yes. But by selecting which feature, which one it will appear.
Automatically it comes, sir. When you conduct
by default, sir. I think by default,
SPSS by default it comes, sir. You don't need to select any.
No, sir. I have done it very many times. But
communalities you don't get, sir. Which version are you using, sir? Sometimes
sir,
it may vary.
This is a 23.
23. Okay, maybe, sir. Maybe, sir. Maybe communality there may be factor. I am using version 25.
Also we get.
You get.
Maybe, sir,
everywhere we get.
Above 18, sir. Above 18 communalities should come,
everywhere.
Sir.
Okay.
In 23.
Sir, one doubt.
Ma'am, we have limited time, ma'am. I need to complete cluster analysis. Give me another 10 minutes. Maybe finally also I can give for question answer.
Okay, sir.
So the last topic also need to be conducted. Very important. I have limited time. Okay. So we move on to cluster analysis. So when to go for cluster analysis? So factor analysis, we have multi variables. You have many variables. Based on the variables, we are going to go for reducing the factor. Whereas in the cluster analysis, used for some classification. Who all comes under which cluster? Let's say you have 50 students in your class, 100 students in your class, and you offered 5 subjects in a particular semester. You have awarded marks for the students. You wanted to classify the students low performer, medium performer, and high achiever. Based on the student performance of 5 subjects, based on the student performance for the 5 subjects offered in a semester, you are going to classify them into 3 groups: low achiever, medium, and high achiever. So low achiever, we need to give more attention. Do you agree with me? So cluster analysis is meant for classification. And then we also come to know who are all comes under cluster 1, who are all comes under achiever, top achiever, who are all comes under the medium achiever. So cluster analysis meant for is a multivariate technique. Group similar observation into a number of clusters based on the observed values of several variables, different subjects, subject 1, subject 2, subject 3 for a particular student and for a given semester. Cluster analysis is an exploratory analysis that tries to identify the structure within the data. Cluster analysis is also called segmentation, or segmentation analysis or taxonomy analysis. We can put them together based on the available data. So more specifically, it tries to identify the homogeneous group of cases if the grouping is not previously known. If you do not know, you have a couple of students, among them you are going to classify them who are all comes under cluster 1, who are all comes under cluster 2, who are all comes under cluster 3. Based on the data you collected, based on the observed data, you're going to group them. So there are two types of cluster analysis. One is called hierarchical cluster analysis. Another one is called K-means cluster analysis. So cluster analysis and exploratory data analysis technique designed to reveal groups based on the distance. Close together observation should be in the same group, and observation in the group should be far away other group. So this application is very huge application in all the fields of biological sciences, customer behavior related, business related, and taxonomical related, etc. So many applications there in cluster analysis. So it has got huge application in medicine, marketing, education, biology, for species identification. For example, for marketing, what are the customer segments? To answer this question, markets researcher may conduct a survey covering needs, attitudes, demographics, and behavior of customers. The researchers then may use cluster analysis to identify the homogeneous groups of customer based on the previous items. For education, what are students group that need special attention? Researchers may measure the psychological attitude achievement characteristics. Based on the psychological attitude and achievement characteristics, we can cluster them. Or based on the different 5 subjects, we can identify the good students, poor students, and average students. Or below average, above average students, we can classify them. We can group them. High achiever, low achiever, etc. So 2 types of cluster analysis: hierarchical. When there is a small sample size, you have very less number of cases, you go for hierarchical cluster. So initially you start with, suppose you do not have some idea, you have some data, collected students' exam marks, you do not know how many clusters will be there. You start with hierarchical cluster, and then if you have formed the cluster, then you can move on with the K-means cluster. You can move on with the K-means cluster. So in the K-means cluster, you come to know who are all comes under cluster 1, who are all comes under cluster 2, and how many students are comes under cluster 1, how many students are comes under cluster 3, and so on. So I have taken one simple example to understand the hierarchical and non-hierarchical cluster, grouping them, classification. So please remember, when you have large samples, you go for a K-means cluster analysis. You have a small sample, you go for hierarchical cluster. And in the hierarchical cluster, you will also get some kind of graphical illustration. We call them as a dendrogram. Who is related with who? Who is related with who? And who is nearer with one another? We'll come to know based on the attributes, the data collected. So we need to key in the data like this. Maybe I will open the file easy. Please go to the file. One minute. What? Yeah. Could you please open the students' marks? Could you please open the students' marks hierarchical cluster analysis? 3. Please delete the last 2 columns. Please to delete the last 2 columns if there is a no, I have worked out this. Could you please delete the last 2 columns? Participant, have you all deleted the last 2 columns? Do you have this column or not? Student marks hierarchical cluster. Do you have this column or not?
Yes, sir. Deleted.
Please delete. So imagine that you have 50 students in a class. Now you know what you call the 10th standard 10. These are the imagine that these are the subjects offered for them. An ID number provided, and these are the marks they have secured. So based on this exam score marks, can we cluster them? Who are all comes under one cluster and who are all comes together? We can go for it. Otherwise, we are in the hierarchical cluster analysis. How many clusters can be formed based on this student exam marks? Shall we run? Shall we go?
Yes,
go to
sir.
analyze. Very, very simple. Go to analyze. Classify hierarchical clusters. Classify hierarchical clusters. Click on it. You transfer the student ID here in the label cases. Transfer the student ID in the label cases. Then you transfer all these subjects, 6 subjects from left side to the right side. Exam marks for 100 marks. Have you all done it? Have you all done it? Then click statistics. Participant, please tell me, have you all done it?
Yes,
Time
sir.
is limited. Click
Yes,
statistics.
sir. Yes.
We don't need to do anything. Agglomeration schedule has been chosen. Continue. And then plot. You can go for dendrogram. You can go for dendrogram. We are not going to specify how many clusters we want. Suppose you also can specify how many clusters you want. Also, you can specify minimum, maximum clusters. But hierarchy cluster, I'm not going to go for it. Continue. Dendrogram means you will get some phylogenetic tree. Click on method. Click on method. Here you can select most commonly used is Watts method. Watts method. Continue. Click Watts method, then continue. You don't need to do any changes. Continue. I think click save. I think no need to do anything here. The hierarchical save, no need to do anything. So in the statistics, I have chosen nothing chosen by default. Plot, I have chosen only the dendrogram. Method, I have chosen Watts method. Continue, then click OK. Continue, then click OK. You will come to know the output. So there are 50 students. 50 students. The system cluster 49 clusters. 50 students with one another. There are 49 clusters are formed. So in first stage, candidate number 12, candidate number 49, they comes under one cluster. Based on the coefficients. So how many clusters can be formed? Can you see here? There are many clusters. This is one cluster. This is another cluster. This is third cluster. There are, depends upon the students. So this we call them as. And the dendrogram, can you see here? The student ID number until ABT04, this all comes under one cluster. These students all comes under one cluster. And this all comes under one cluster. And this is the fourth cluster. This is the fifth cluster. And then this group are related with this cluster at this distance. And this group are related with the fourth cluster. And finally, this group are related with this cluster.
Excuse me, sir. Can you please once again repeat?
Oh, you missed it, sir?
Yes, sir.
Okay, so go to analyze.
Yeah, that part is
Classify.
done, sir. Just interpretation, sir.
Oh, you want me to interpretation?
Interpretation, sir. Yes, sir.
Okay, so in the study, we have a 50 candidate. So 50 candidate, there are 49 clusters are formed. 49
Yes, sir.
clusters are formed. So who are all in the first stage? So 12th candidate and 49 candidate. Second stage, 7 candidate and 8th candidate. The relationship is this. 24th candidate and 25th candidate. The relationship is this. So this is for agglomeration. Who are all comes under which cluster and what stage?
Okay, sir. Yeah, understood.
Okay, what stage? Okay. So there are 50 students, 49 clusters are formed. For the last stage, first candidate and 13th candidate, they are grouped together. And this is meant for qualitatively we can have some idea what are the candidate or comes under which cluster. But I prefer the dendrogram, easy for us to interpret. So there are 4 group can be created. Hierarchical cluster, we initially we did not know how many cluster will be there. How many cluster will be there, we do not know. But we have done for the hierarchical analysis. The dendrogram shows that there are 4 distinct clusters. Maybe we can reduce the what you call the graph size. Easy. Double click the graph. Double click the graph. Right click, properties window. In the chart editor, properties window. Chart size. You can reduce the size of the dendrogram. The height can be reduced. Maybe 500. Resize. So chart editor. Now the graph somewhat easy, right? To view your this thing. So this is cluster 1, this is cluster 2, this is cluster 3, and this is cluster 4. So these are the students that comes under each cluster. So we can classify the 50 students into 4 cluster based on the similarities, based on the relationship. Yes or no? So this can be presented. You do not have any idea, you please proceed with hierarchical cluster analysis. If you are already after having this hierarchical, you can go for a K-means cluster. Now, please go to the same data. Please go to the same data. Let us run. Go to analyze. Classify. This time you click K-means cluster. This time you click K-means cluster. Student ID, you place it here. And then you select all the 6 items and put it here. In the K-means cluster, I have already mentioned, we can specify the cluster based on the hierarchical cluster analysis. I'm going to go for, I'm going to convert them into, split them into 4 group of students, 4 clusters. And I'm interested in who are all comes under which cluster. Yes or no? Please put the remove 2 into 4. Iterate, we don't need to do anything. Save. Can you please see here? Cluster membership. We come to know which cluster a particular student comes under. Cluster membership. Continue. Option. You can also click for ANOVA table. ANOVA table. Continue. So in the save, just I have chosen cluster membership. Continue. In the option, I have chosen ANOVA. Continue and then click OK. Please tell me, the first one has got, there are 4 clusters. Initial cluster centers. So you are provided with the cluster 1, average of all the subjects. Cluster 2, the Tamil average is 100%. Cluster 3, Tamil average is 38. Cluster 4, the average of the Tamil marks is 87. Similarly, for cluster 1, English is 56, second cluster 99. So this is for you to give some idea. See here, cluster number 3. Cluster number 3, all the subjects, 38 to 40. Can you please see? So these all students are
weak students.
Shall we go cafe, sir? 5 minutes or another 5 minutes? We'll go to cafe, sir. Okay, another 5 minutes. Another 5 minutes. I'll come back. Oh, okay. So participant.
Yes, sir.
So where we are now? Yeah, the results.
Yeah.
So initial cluster
in the third cluster.
Yeah.
Third cluster.
Yeah. So iteration history actually is not needed actually. And then this is the final cluster after final formation. And this is what the average of these are. Cluster 3, cluster 1, cluster 2, and cluster 4. So we need to see whether each subject is able to influence the cluster formation or not. Whether each subject is it significant to form a cluster or not. If any subject is not significant, we have to drop out. So here, see that all the subjects, Tamil, English, biology, maths, physics, chemistry, it shows that all the 6 subjects are significantly influencing the cluster formation. Significantly influencing the cluster formations. Yes, fine. If any one of the subject greater than 0.05, so we have to remove the particular subject for cluster formations. Now, go to the number of class cases. You have 50 students. Okay, how many students are comes under cluster 1? There are 14 students. Cluster 1. There are 13 students. Cluster 2. 9 students are comes under cluster 3, and 4 students are comes under cluster 4. Agree? Agree? So 50 students are classified into 4 clusters, but you are interested in who are all comes under cluster 1, who are all comes under cluster 2, who are all comes under cluster 3. We need to know. Please go to the data file. Please go to the data file. Can you please see here? So the first student, he comes under cluster 4. Second student, cluster 4. Third student, cluster 2. So these students all comes under cluster 2. Says or no?
Yes, sir.
Says, okay. So now, shall we verify the data? Shall we verify the data? How many 4s are there? How many 2s are there? How many 1s are there? How many 2s are there? Shall we go to analyze? Descriptive.
Yes, sir.
Frequencies. You can transfer the cluster number. You can also go for a chart, bar chart. Click OK. See that table 14, 13, 9, 14. 14, 13, 9, 14. Say sir. Number of cases.
Yes, sir.
The number of cases in the previous table and the cluster number now 28%, 26%. So this is a cluster number case. So based on some attribute.
Sir.
Yes, sir.
Yeah. So suppose instead of these marks, suppose the students are graded, and from the grade also can we conduct this cluster analysis?
Yes, sir. Any variable you can go for cluster analysis.
Okay.
Based on some attribute, based on the customer. For example, you have 400 employees in your organization. You asked some attribute like, for example, their salary, their number of years of experience, and number of publications, and their positions. How we can classify them? So how many cluster of employees can be formed based on the data collected, years of experience, male and female, and their contribution to the university, publications, having the amount of research projects. So who are all top achievers? Who are all weaker? So who are all poor among the performance, academic performance in a university can be conducted. So think about it, where this application will be useful in your field of study. Participant, so I have given you a couple of exercises also for you to practice. So I hope you would have got some idea, not thoroughly, some idea. I would have given you some interest to learn the multivariate data analysis like multiple regression, logistic regression, and the cluster analysis and factor analysis. I think I would have given you some basic idea and knowledge you would have gained this workshop. I hope the session was useful to you, and I wish you all the very best to you. Thank you.
Thank you very much, sir.
Thank you.
Thank you very much, sir.
Thank you.
Thank you, sir. Thank you.
Thank you. We'll see you.
Thank you, sir. Thank you. We appreciate.
Sir, just a minute, sir. Sir, one more question.
Yeah.
Sir, I have sent a mail to you regarding my question. I requested.
I received, sir. Oh, your name, please.
Santpal Yadav, sir.
Yes, sir. You can do only the frequency analysis, sir. There is no such hypothesis. Only frequency analysis can be conducted, sir. It's a very simple data. You cannot do any kind of hypothesis.
Sir, this is I am doing the PhD on these topics.
But
I
very
want to
limited
go forward.
data, sir. Is it enough
No,
for your
sir.
PhD? Is it enough
I
for
am
your PhD thesis, sir?
I am expanding this question here also. This is the short form of this question.
Okay. So
I
then
am
I need
taking
to
the
know
seven.
actually I need to know your objective, sir. Based
Sir,
on this data.
I am studying the
based on-
problem.
Okay.
Problem of industries, small scale industries.
Okay.
The problem like finance problem, marketing problems.
I understood,
and,
understood, sir.
10
But I need to know your full hypothesis and your questionnaire, sir. If you have developed your full questionnaire,
yes, sir.
so that I'll have some idea. We can go for factor analysis. You can go
Sir,
for
in
structural
future,
equation modeling.
I have make a contact to you in this regard.
Definitely, sir. You can contact me. I'll help you out
Via mail or